times the second. The only difference between product and quotient rule is minus the first times the derivative of the second. In this case, the second being the denominator. All over the denominator squared. Okay? Am I done?
No.
No. I still have to take a derivative here and here. I still have some work to do. But now this isn't a quotient rule problem. This is just the derivative of sine. What's the derivative of sine? Cosine. Minus. What's the derivative of cosine?
Negative sine.
So I'm just going to change this to a plus. Am I done?
Yeah.
Sure you are. If I wanted the derivative of a function, there it is. On a test, if that's what they asked for. Don't go any further on a test. The only thing that can happen is you can waste time and you can possibly have an algebraic error. Does that make sense? If I just asked for a derivative, you're done. Now, if it was multiple choice and you needed to find the answer, you may need a little more work. So let's do that. What is cosine times cosine? Cosine squared. I put sine times sine. So then what is sine squared plus cosine squared equal to?
1.
Look at that. 1 over cosine squared x. Now what? It's not cosecant, it's what? How do I remember?
It's the opposite of what
Yes. 1 over cosine is what? The secant. 1 over cosine is secant. How do I remember that? It's not what it should be. 1 over cosine is the secant. So 1 over cosine squared is secant squared. Which one of these are the correct derivatives for tangent of x? All three. All these are all good. If you need to graph it, like you can put this into your calculator, so you're going to be doing that a lot. You know what I'm saying? What I want you to memorize is this. This is what you need to memorize. Okay? You need to know that the derivative, and I don't expect you to do this every time. Does that make sense, Katie? I expect you to know by the end of today, at the end of this week, that the derivative of tangent is secant squared. What is the derivative of tangent? I didn't hear everyone. What's the derivative of tangent?
Secant squared.
And you need to say it every time I ask. The more you say it, the more you'll remember. Calculus is two big things. It used to be really all memorization. That changed in the mid-80s. Now, a big part of it is memorization. You need to know this. You need to know derivative of tangent is secant squared. And the other big part of it is conceptual understanding. But you need both. So if you're really good at just understanding things, then work on your memorizing these rules. And if you're really good at like memorizing the rules, then spend a lot of your time on the conceptual understanding. Does that make sense? But you need both. Now what I would do, like I said, the majority of people that passed the test last year made their flashcards. I would put these on your flashcard. I'm not going to make you do it. I'm just telling you, you have time on the bus. You have time on the train. You have time when you're watching Tom and Jerry at commercial time to go through these. That cat is never going to get the mouse. What is the derivative of sine? What's the derivative of cosine? What's the derivative of tangent? Okay? And then the derivative of cotangent is, from your notes, negative cosecant squared. Sine is cosine. Cosine, negative sine. Tangent, secant squared. Cotangent, negative cosecant squared. Sine is cosine. These are kind of paired together. You see how they're kind of paired together? Sine is cosine. Cosine is negative sine. Tangent is secant squared. Cotangent is negative cosecant squared. You see that? What's the derivative of sine?
Cosine.
What's the derivative of cosine?
Negative sine.
What's the derivative of tangent?
Secant squared.
What's the derivative of cotangent?
Negative cosecant squared.
Negative. It's the bad one, as I say. Here's the good one, and then the cosine's kind of the bad one in the group, so it's got the negative on it. Here's the good one. Here's the bad one in the group. It's got the negative on it. Let's do this one. The derivative of cosecant of x. Cosecant of x is the same as... what is it the same as? Not derivative. What is this the same as? How do I remember that cosecant is 1 over sine? It's not what it should be. I want to take the derivative of 1 over sine of x. If I wanted to take the derivative of 1 over sine of x, what type of problem is this? It's a quotient rule problem. What's the quotient rule? Derivative of the first times the second minus the first times the derivative of the second all over the second squared. In this case, second is denominator. So if I take the derivative of that, take the derivative of the first times the second minus, again, treat it the same as product rule, only this has a minus in it. First times derivative of the second all over denominator squared. Again, the derivative is equal to this. I'm asking for the derivative. Am I done yet? No, I still need to take the derivative. Let's see. Here and here. What's the derivative of this? It's 0. Be careful. The derivative of a constant of the line y equals 1 is 0. The derivative of x is 1 times minus 1. What's the derivative of sine?
Cosine.
All over. Am I done?
Yeah.
Sure. You are. On a test, if it's true response, this is a derivative of cosecant of x. That's it. If you wanted to clean it up, okay, let's do that. If it's multiple choice or just to see what I want you to memorize. This is gone. 0 times sine x is gone, so I have negative cosine x all over sine squared x. Is that a derivative? Is that it? Sure. It's not the one in the book, so we can keep on going, but this is fine. This is a valid derivative. Either of these are the derivative of cosecant. If I wanted to know what the rate of change is of this function for any x value, this will give it to me, or this will give it to me. Okay? Now I'm just going to do a little manipulation here. I'm going to rewrite this as is that the same thing?